simplest formula, also known as empirical formula. Let's compare these two formulas. You'll notice that both of them have the same ratio of atoms, 1 carbon atom to 2 hydrogen atoms. Which one would you say is the simplest formula? You would likely say this one, because it can't be reduced any further, and that's true. That is the simplest formula. The C2H4 is called a molecular formula. This lesson will show how to calculate the simplest formula given experimental data. A different lesson will show how to calculate the molecular formula. Let's start by looking at a typical question. A reaction between copper and chlorine gave a compound containing 47.2% copper and 52.8% chlorine. Find the simplest formula. As we look at this problem, all we have is percentage. There's nothing here about mass in grams. And without that, how are we going to determine the number of moles of copper and chlorine that we need to come up with the formula? So what we'll do is assume that we start out with a certain amount of the compound, say 100 grams. This is what your written solution should look like. Now, you may ask, does it have to be 100 grams? Well, no, it doesn't. It can be anything you like. It could be 10 grams, 250 grams, or 1,000 grams. The reason I suggest taking 100 is because it's much easier to determine 47.2% of 100 than for any other number. So if we do that, then we set up a table here showing element, mass, moles, and mole ratio. Let's put in our element symbols, copper and chlorine, and now the mass. Since we assumed 100 grams of the compound, then 47.2% of 100 is 47.2 grams. And the same idea for chlorine. Now we do the conversion to moles. Remember our formula here. The number of moles is found by taking the mass of the substance and dividing by the molar mass. So that means we'll take 47.2, divide by 63.5. And by the way, let me pause here for a moment. The 0.5 should be retained and not rounded. There are 3 or 4 elements whose atomic masses are close enough to a half that rounding would give you an error. Copper and chlorine are 2 of them that should never be rounded. In this case, we get 0.743 moles. Do the same with chlorine. 52.8 divided by 35.5, the molar mass for chlorine, and that gives us 1.49. Now, it may not be immediately obvious that the ratio is 1 to 2, so what we do is divide each ratio by the lowest number. Before I do that, let's consider if we have several elements here, for example, then you'll have several different decimal numbers. So what you do is take the smallest one, wherever it is, divide it by itself, like this, and that means you get 1. Now, because we took the smallest number, that guarantees that all the other numbers will be greater than 1. We see here a ratio of 1 to 2, whole numbers, so that's nice. The simplest formula is then CuCl2, and that basically is how you find the simplest formula given experimental data. There may be some cases, however, in which numbers like the 2 here will not be a whole number. It may be 2 1/4, 2 1/2, or 2 1/3. This can happen. I'll show how to deal with this now by doing one more example, which has a slightly different question. An arsenic compound was analyzed and found to consist of 1.51 grams of arsenic and 0.80 grams of oxygen. Determine its simplest formula. Notice here that we're not given percentages, but the actual masses of the elements in grams. You may see a problem like this. This time, no assumption of 100 grams is needed because the question already gives us the masses. Start out by noting the molar masses of the elements. Arsenic is 74.9 grams per mole, oxygen is 16. We can now set up our table, show the elements here and their masses. The moles, again, are obtained by using our formula. Moles equals mass over molar mass. In the case of arsenic, 1.51 over 74.9 equals 0.020. And for oxygen, we get 0.050 moles. Now we'll take the smallest number, 0.02, divide each number by decimal 0.2, obtain 1 as expected, and in the second case, 2.5. Now we don't have neat whole numbers as we did previously. So you ask yourself, what number can I multiply 2.5 by to get a whole number? Well, that would be 2, which gives us 5. Multiplying the first one also by 2 gives us 2. And now we have the new ratio 2 to 5, so our simplest formula is then AS205. So that ends this one. But we may have other cases in which ratios end in 1/4 or 3/4. Do not round these numbers off. Ask yourself, what number can I multiply by to get a whole number? In this case, the word quarter suggests the number 4. So if you multiply 1/4 or 3/4 by 4, you'll get a whole number. In the case of 1/3 or 2/3, the word third in each case suggests multiplying by the number 3, and that's what you would use. In the case of a half, that's simple enough that multiplying by 2 always gives us a whole number. Now finally, there are a few other cases where the ratios will be somewhere in between. For example, let's say the mole ratio is 1 to 1.2. I know it may not be immediately obvious that this ratio is 5 to 6. A little trick to get this is to simply multiply both by 10, and then when you see 10 to 12, divide both by 2, then it's easier to see that the ratio is 5 to 6. Another case might be 1 to 1.4. Again, multiply by 10 divided by 2 and get your ratio of 5 to 7. A third example could be 1 to 1.6 leading to 5 to 8, and a fourth one would be 1 to 1.8 leading to 5 to 9. This will take care of all the instances that you're going to come across, and so this takes care of simplest formula. I'll leave you with a final question. Here's a compound with 3 elements: potassium, chromium, and oxygen. You can pause here, work it out for yourself, and come back to see the answer. Here it is. I hope you got this okay. If not, this might show where you made your mistake. This ends the lesson on calculating simplest formula.